Okay, hey, we're going to start off this last part. This is the bottom of this assignment if you're in the assignment on literal equations. We're getting to those kind of questions that are a little bit tricky. If you tried to, maybe you struggled, so you're coming back to the video afterwards. So to start this off, we need to talk about the word factoring that you probably haven't seen for a couple years. A factor is a number that evenly divides into another number without a remainder. So for instance, if I asked you what are the factors of 12, you'd have to ask yourself, well, what numbers go into 12 evenly? So you could say 2, because 2 times 6 will give you 12, right? You could say 3, because 3 times 4 is 12. You could say 4, because 4 times 3 is 12. Would 5 work? No, 5 doesn't go in evenly. Evenly means without a remainder, so you don't have any decimals. So 5 doesn't work. Would 6 work? 6 goes into 12 2 times. 7 work? No. 8? No. 9? No. 10?
No.
12? Yeah, 12 is a factor of 12 because 12 goes into 12 one time. And 1 is also a factor. The reason why I didn't write down 1 is because 1 doesn't really change a problem. It is a factor, but if I divide something by 1, it's just going to give me the same number. It's actually the identity property of division that if you divide anything by 1, you get the same number. So you don't really need to use it. So I know what factors are. They're the numbers that evenly go into it. So you say, well, why do I need to know that? Well, factoring is the reverse of the multiplication process. Let me try that again. Factoring is the reverse of the multiplication process. It is the opposite of distribution. So what is a common factor? So what I'm saying is, if I gave you a problem like this, 5 times x plus 2, hopefully you know how to distribute. You can distribute by multiplying through. 5 times x gives you 5x, and 5 times 2 gives you 10. So that's the distributive property. But when we're solving, sometimes we have to take it apart. And so when we talk about taking it apart, we're saying, what common factor do both of these numbers have? Now the variables are different, but what number can go into both? Well, I know that 1 can go into 2 and 1 can go into 12, but that doesn't change anything. I know that 2 is a factor of 2, right? Is 2 also a factor of 12? Yeah, we've already shown that. So I could actually factor out of this equation a 2. That would leave me, if I pull the 2 out of this, what's 2 divided by 2? That's 1x. Do I really need that 1? No. And minus 12 divided by 2 is minus 6. So what I've done there is I've taken the problem and I've said x minus 6m equals 2. Notice I put the 2 in the back and this way I put it in the front. Doesn't matter. Is this different than this? No. It's depending on how you want to do it. If you want to pull out to the back, that's fine. A lot of people like to put theirs in the front because it's the way they've seen it their entire life, and so they're like, I want to see it. And so you say, okay, I understand kind of what factoring is, but why would I use it to solve a problem? I'll show you. All right, so first let me give you a simple problem. Here is a simple problem. Here, obviously, if this was a regular equation and I said solve for x, you could say, oh, well, before I can solve, I have to use step 0. Step 0 is simplify. Simplify means find the two terms that are the same and add them together. So I'd say, oh, 3x plus 5x is 8x, right, equals y. And then I would say, okay, now that I've simplified, I can identify the variables. So first I do my lollipop. Ba-dum-bum-bum. And it says I'm solving for x, so there's only an x here, so I'm going to go circle the x. And I say, okay, what? The only thing left on that side, it's an 8, and the 8 is touching it, so that would make it a coefficient. So I have a coefficient of 8. How do I get rid of coefficients? I divide by 8, right? And so if I divide one side by 8, I have to divide the other side by 8. So 8 divided by 8 is 1. That leaves me x. And y divided by 8, well, I don't know what y is, so guess what? I'm just going to say y divided by 8. So I know x is whatever y is divided by 8. So that's how you would solve it. But let me show you how you would do that problem by factoring. I did that exact same problem that I had, which was y equals 3x plus 5x. If I did it by factoring, I could say to you, okay, if I look at this side of the equation, do these have any factors the same? You're like, no, Mr. Craig, 3 is a prime number. It's only got 1 and 3, and 5 is a prime number. It's only got 1 and 5. They don't have anything in common except for 1, and 1 doesn't change anything. But I would say, wait a second. They also have what?
An x.
X, because they're actually like terms, so that means their variables are the same. So I can pull an x out of this, and I can pull an x out of this. I can pull that out, and if I pull that out, what's left inside here? I have a 3 plus 5, and I have the x out to the side. Now, what's 3 plus 5? 8. And now I can solve just like up above when we did this and had 8x. So you see, so you're saying, okay, I kind of get that. Let me show you what that looks like in a literal problem. The reason why here you could just add like terms, I don't know why you would distribute, why you would want to factor here, because you can just add the like terms. But what happens if I see we have x and x here, but guess what? The a and the b are not the same. So these are actually not like terms because the variables have to be the same. These are not the same. They have an x and this has an x, but this is ax and this is bx. So they're not the same. So I can't add them. I can't do anything. And it says solve for x. So I can't move any forward unless I do something called factoring. It's the opposite of distribution. And so I say, okay, well, just like in this problem, I notice that I have 2 x's. So I'm going to do this using the area model. If you don't remember that, we did this in class. If you haven't been in class, that's okay. The area model is where I take the thing and I say, okay, I have that ax, right? What can I pull out of both of them? I can pull out a x. If I pull an x out of both of them, that leaves here an a, and that leaves here a b. And so what's left here is y equals a plus b times x. You're like, okay, that looks kind of scary, Mr. Craig. You're right. But let's go back to solving this equation now. So if I solve this equation, now that I've factored out a common factor, they both have an x, now I'm saying, okay, I start with doing my lollipop. Boom, boom, boom. I'm solving for x because they told me that's what I'm solving for. So I'm going to circle my x. That's my variable. Now I say, okay, what's next? I underline the coefficient. So you say, well, is b the coefficient and a the constant? And the answer is no, because this is in parentheses. That means all of this is touching the x. That's why we had x's in both of them, right? So this whole thing in parentheses is the coefficient. And so how do I get rid of times a plus b? I divide by a plus b. And if I divide one side of the equation by a plus b, then you have to divide to the division property of equality. It says what you do to one side of an equation, you must do to the other in order to keep that equation balanced. And so this looks really scary, but I just have a over b over a over b. Anything over itself is going to equal 1, except for 0, because 0 over 0 is not 1, it's 0. And what's left here? My x. And over here, I got y equals, y divided by a plus b. I don't know what that is, so I'm just going to write it again. Y over a plus b. And you don't need the parentheses because these are grouping symbols, or you can leave them, it doesn't matter. But I now know x equals y divided by a plus b. Where up here, I couldn't. So that may have been a little scary. Let's try a different one. Let's try now we're kind of on the same sheet of music. So again, here, obviously I could add the two y's together. I have an invisible 1 in front of this one, right? The coefficient of this one is 1, because it's by itself. And I would go 1 plus 9 is 10y, and then I would divide. That's obvious, right? But if I had to factor, I would say, okay, if I put these in boxes, what can I pull out of both of these? One doesn't really pull out, right? But I could pull a y out. And this is where things get tricky and why the model helps. Because some people pull the y out and they don't put anything here. But I need a place marker. Because how many y's were here?
1.
1. So I need to have that box going, okay, I pulled out a y, I have the 1 left. Because if not, and I just pull out the y, if some people just go y and say, oh, what's left is 9, well, y times 9 is 9y. It's not y plus 9y. So I have to leave that place marker because I pull the y out, y's there. And then I can pull a y out of that one. So I'm pulling those y's out, and that's 9 left, right? And so now I have y times 1 plus 9 equals 7. And now I can go y times 10 equals 7. And then we already know how to solve it. I'm kind of just doing this fast because this is not what we're trying to get at. But I can divide by 10 and divide by 10. This cancels out. I get y equals 7 divided by 10. Now again, would I do this if I had just one variable? No, I would just solve it like we did. 1 plus 9 is 10. However, when you have a literal equation where you have nothing but variables, I need to solve for the variable. In this case, they're asking me to solve for y. So I'm like, okay, oh crap. I have a y here and a y here. How am I going to solve for y? Again, just like over here, we're going to try to factor. So I say, okay, if I pull out a y, I get a y out, but again, I need to leave that place marker, right? So I have to leave a 1 there. And if I pull a y out of here, what's left? N. So this is a 1. Okay, so that means I have y times 1 plus n. And that really confused me with that place marker. And now I have y times 1 plus n equals m. I'm still trying to solve for y. So this is where we can do our lollipop. Boom, boom, boom. And I'm going to say, okay, the variable I'm solving for is y. What's touching y? Again, we talked about this last time. What's touching y is all of this stuff in the parentheses. So the coefficient is 1 plus n. How do I get rid of coefficients? Well, the opposite of multiplication is divide. So I'm going to do the division property of equality. So I divide the entire side by 1 plus n. If I divide that side by 1 plus n, and divide this side by 1 plus n. And 1 plus n over 1 plus n cancels out to 1. And I get left with a y, because I could put a 1 in front of it, but that just seems silly. And then m divided by 1 plus n is just m divided by 1 plus n. Some people out there in honors might say, can I simplify this? You can, but it doesn't really help the problem. So if you want to ask me about that specifically, you can email or text. So that's solving. That's a really tricky one. Try some of the problems. You can always come back to the video. But if you're not getting it, this time I'm going to skip this side. Obviously I would add these together, but I think I'm just going to go straight to this. Because this, you know that you're going to just go, oh, these are like terms. I need to simplify first. I get 13y equals 13. Divide by 13, because that's the coefficient. Divide by 13, you get 1. I got that. 1 equals y. I'm good. Or y equals 1. But this is where people get stuck. If I said solve for x, you'd be like, cool, I can circle the x, get rid of it. But because I have two y's, I need to factor first. And again, because it's a little equation, I don't necessarily have numbers. I have a number here, but I just want to get rid of those y's. So I say, okay, how can I factor out those y's? So I say, okay, if I pull a y out of both of these, that leaves y out. Over here, what's left?
3.
And over here, what's left?
X.
So I end up with, and people, the reason why I do the two boxes, just like in the last slide, I put the two boxes so you make sure you have to have a number in there. Like in this case, instead of leaving it blank, you had to put a 1 there. You can't let those boxes be empty. So now I go, okay, let me rewrite this. M equals 3 plus y.
X.
Oh, that was a test. You passed. 3 plus x times y. Now it's time to identify and simplify. So, a circle, drop it down, lollipop. Ba-dum, bum, bum. What's my variable? Y, because that's what we're solving for. What's my coefficient?
The parentheses.
Because that's what's touching the y. How do I get rid of a coefficient?
Divide.
Divide. And so I would say some people actually realize that while little equations seem confusing, in a lot of ways they're easier because you don't actually need your calculator, because since I don't know what Oops, that's supposed to be an x. I looked at the m. Since I don't know what m or x is, I can't solve. So I just have to do the steps. It just proves to people that you know how to do the steps to solve. So I end up with 3 plus x. And yes, you can put parentheses around it, or you don't have to. Equals y, because this equals 1. Hopefully that helps. These are as hard as they get. Boom. And so finally it gives us this slide. And the reason why we do this slide every year is people try, a lot of times say, well, how come I don't just solve, instead of solving for x and then figuring out stuff, like evaluating, why do I just plug them each time? Well, the reason is because it's a saver of time. If I know this is my equation, but I need to find out what y is every time I substitute in something for x, having y alone will make that a lot easier. So what I'm saying is, if I want to solve for y, I'm going to do my lollipop, and I probably should do that in a different color because we've been doing variables in red. Now, I'm solving for, find the value of y, so I'm solving for y. So I circle my y, right? Now I say, okay, I've circled my y, it's on this side, there's no other y, so I don't have to do any factoring in this case. And then I say, okay, what's touching the y? I see a plus 3, which Nelson always says, make sure you keep the sign in it. So we're going to make sure we get that whole plus 3. This is my coefficient. And I say, okay, do I have a constant? Yeah, I see something on this side of the equation that's not touching that symbol, that addition operation is separating it from the 3y. So that makes that the constant, but it's not just the x, it's the 6x. So this becomes the constant. And now it's get rid of the constant, get rid of the coefficient, and you have your answer. So how do I get rid of plus 6x? I have minus 6x. If I do it to one side, I have to do it to the other. And 6x minus 6x is 0. That leaves me with 3y. And now this is where things can get confusing for people. Some people want to just put 15 minus 6y, and that's completely okay. 6x, thank you. Ooh, don't do that. X. Because that's the way you wrote it. And that's completely okay. But some people are like, oh yeah, you're supposed to put variables before constant, and they'll go negative 6x plus 15. That confuses a lot of people. For what we need you to do, since we're going to be substituting values in, you can just leave this as it is. So, but if you want to write it that way, that's also okay. So now, I've done this, got rid of the constant, done. Now I have to get rid of the coefficient. How do I get rid of times 3?
Divide.
And if I divide one side, let me change my colors up. I'm being very bad, being lazy. If I divide one side by 3, I have to divide the entire other side by 3. This goes to 1, and I get y equals, and I could leave this as 15 minus 6x over 3, but if you notice, does 3 go into 15 and 6?
Yeah.
It does. So you can leave it like this, or if you want to simplify it, especially the honor students, 15 divided by 3, that's 5. And negative 6 divided by 3 is negative 2x. So y equals 5 minus 2x. Now that I've done that, it wants me to evaluate. Y equals 5 minus 2x. And for those of you who switched it around, you might have ended up with y equals negative 2x plus 5. These are the same problems. That's just the associative property of subtraction. You can move things around as long as, or actually it's addition, as long as you keep the symbol with it. It's the associative property of addition. But now it's asking us to substitute the value when x, this right here is called set notation. It's a set of numbers. It means these numbers are in the set of x. And so I have to find 3 answers. So instead of solving it here, where I would have plugged in 2 and tried to solve for y, plug in 5 and try to solve for y, plug in 10, try to solve for y, because y is alone, all I have to do is substitute the values in here, and I can jump to the answer. Y equals 5 minus 2. And we're saying substitute in 2, so I put in the 2. And you can do that pretty quick, can't you? 2 times 2 is 4. And 5 minus 4 is 1. So when x is 2, y is 1, right? Now I can jump back and say, okay, now I'm going to substitute y minus 5 equals 5 minus 2 times x is 5. So I substitute in a 5 there. Okay, I can do that pretty quick. Negative 2 times 5, because the order of operations is multiplication before subtraction. It's negative 10. And then 5 minus 10 is negative 5, so y equals negative 5. So when x is 5, y is negative 5. And then finally, for the last one, I'm going to find for 10, I can go y equals 5 minus 2 times, and I substitute the value of 10 in. And again, negative 2 times 10 is negative 20, because it's the order of operations as multiplication before addition or subtraction. And I put a 5 there. Remember our GEMDOS. Multiplication or division comes before adding or subtraction. And now I go 5 minus 20 is negative 15, and so y equals negative 15. And so, instead of having to solve the problem 3 times, what if I had had like 10 numbers in this? I'd have to solve this 10 times. Instead, I can just substitute the value in to my calculator and get the answer. All right, that ends this lesson. Good luck.